All right, today we are starting section 2.3. Remember, tomorrow we are going to review, and then on Friday we are going to have a quiz over what we've covered this week. Today we are going to solve inequalities using multiplication or division. So yesterday was addition, subtraction. Today, multiplication, division. For our warm-ups, this is a review of what we did yesterday. So we are going to solve these and graph our solutions. How would I solve the first warm-up? Good, we would add 3 on both sides of that inequality. We get P is greater than 11. So when I go to graph that, I'm going to count by 3s. If you wanted to count by something else, that's fine. When I count by 3s, I don't actually put an 11 up there. So I have to know 11 would fall between which two numbers? 9 and 12. Probably a little bit closer to the 12. Open or closed?
Open.
Open, Jasha?
I thought when you do the line, I thought you can just put like 11 and 12 and then 10 and 9 instead of doing all that.
I want 0 on the number lines. If they give you a number line already filled in, that's fine. But if you have to make a number line, I want to see 0 on it somewhere. Good question. All right, we put an open circle at 11 because there's no equal to bar. Good, and we are going to shade it to the right because it is a greater than symbol. Questions about warm-up number 1? Warm-up number 2, how am I going to solve that one? Add 5 on both sides. When I do that, I get x is less than 12. I'm going to count by 4s this time. Works out nicely because I get a 12 on there. Open or closed at 12? Open. There's still no equal to bar, shaded to the, well, which way? Left, because it is less than. Questions, concerns about those? All right, remember your rules for multiplying and dividing positive and negative numbers. So you don't necessarily need to write that sentence, but we will talk about it. A positive times a positive gives you a positive. So a positive times positive equals a positive. What about a positive times a negative? Gives you a negative. What about a negative times a positive? And a negative times a negative is positive. So remember, same signs comes out positive, different signs comes out negative. I believe most of you know that. I don't think you need to write that down. Okay, also another thing we have to remember, we've already talked about it, the variable must be on the left before you graph. Okay, so there's nothing really new on this slide that you have not already known or been told. Do we have questions about those two rules? Okay, we'll keep it moving then. All right, so these ones, again, are going to be similar to solving equations. They just don't have an equal sign, they have a different symbol in there. So on number 1, what would we do to get x alone?
Times A on both sides.
Very good, we would multiply both sides by 8. On the left side, what happens to those 8s? Cancel out. We're left with x is greater than negative 40. Good. Negative times a positive gives us a negative. We should be graphing that on a number line. Right. Good. I like counting by 10. 0. Oop, but I want it on the other side. 0, negative 10, negative 20, negative 30, negative 40. Open or close circle at negative 40? Open, good. Still no equal to bar. Shaded to the right because it is greater than. On number 2, how am I going to get x alone? Divide by 3. Very good. We're trying to get rid of whatever's by the x. So we divide. When we divide negative 24 by 3, what do we get? Good. Negative 8 is greater than or equal to x. Are we ready to graph this?
No.
What needs to happen first? Good. We need to switch the whole thing around. So when we switch the x and the negative 8, what else switches? The symbol in the middle. So instead of a greater than or equal to, it's now a less than or equal to. We set up our number line. Put a 0 on there. I'll count by 4s. Open or closed at negative 8? Very good. Closed. And then this is the part that gets tricky. Which way do I shade? To the left. Why to the left? Good. We switch the symbol around. So we have to go by what it is when the variable is on the correct side. So then it's less than, we shade to the left. This is really not a whole lot different from what we were doing yesterday. The only difference is we're solving using multiplication and division instead of addition and subtraction. Good. Multiply by 7 on both sides. That gives us n is greater than or equal to negative 7. Are we open or closed at negative 7? Closed. Again, I counted by 2, so I need to put my point where? Good. Between the negative 6 and the 8. Closed. Shaded to the right. Good. Greater than, we go right. If it helps, as long as your variable's on the left, you can think about which way the point of your inequality symbol is facing. So if this is pointing to the right, we shade right. All right, number 4 was maybe a little bit more challenging. Dominic, what'd you do?
Oh, change 1 over 5 to 0.2 and then divided each side by that number.
Interesting. That does work. Did anybody do it a different way? He changed the fraction into a decimal and divided both sides by the decimal. It's not wrong, but there's a different way that we've talked about more often in class. Multiplying by the reciprocal would also work. Either way, we should be getting the same answer. So if we multiply by the reciprocal, 5 over 1 is really the same as 5. Okay, so by our variable, the fractions canceled out. So we are left with, good, negative 32 is greater than or equal to W. Are we ready to graph there? Very good. We need to flip it around. So everything, including the sign in the middle, flips around. Okay, now we're ready to graph. Open or closed at negative 32? Close, shaded to the left. Very good. Anybody have questions, concerns, or need more time with this slide? Okay, we'll keep going. All right, number 5. I'll rewrite these a little bigger again. On number 5, what are we going to do to solve? Divide by 4. When we divide by 4, we get b is greater than or equal to 9. I'll count by 3s. Are we open or closed at 9?
Close.
Shaded to the
Right.
right. Good. All right, on number 6, what are we trying to move or get rid of?
1.5.
Trying to get rid of the 1.5. So what should we do to get rid of it?
Divide.
Divide. Good. This is where having a calculator would come in handy. It's going to be kind of tricky to divide by a decimal in your head. So this is a problem that is definitely way quicker if we have a calculator. Dominic, did you get it for us?
No, but may I say the answer?
Sure.
It's a negative 12.
Negative 12. Anybody else agree? Okay, I think that's what we should have gotten. Negative 12 is greater than Q. Are we ready to graph? No, we need to switch the variable to be on the left, which means our symbol flips over as well. Notice that when we flip things around, we're not changing any of the signs except for that symbol in the middle. So this was a negative 12. It's still a negative 12. We're just rearranging it. I'll count 3s would work. I'm going to do 4s just because I made a small line there. Open or close at negative 12.
Open.
Shaded to the...
Right.
Why the left?
Oh, I forgot to switch.
Good, we switched it, so now it's a less than. We go to the left. We feeling good about these? When you multiply or divide an inequality by a negative number, you will need to switch the inequality or flip the symbol around. So the symbol can flip around when we rearrange things. The symbol also has to flip if you multiply or divide both sides by a negative number. This is one thing that makes inequalities a little bit trickier than just equations. So we didn't have to worry about this before. I'll give you a second to finish writing that statement down before we start talking about 7 and 8. So on 7, if we're trying to get y alone, what are we doing to both sides? Good. We're dividing on both sides, and the number that we're dividing by on both sides is a negative. So that sentence that was at the top says that this symbol in the middle has to switch because we divided both sides by that negative. So it's going to flip over. Negative 35 divided by negative 7 is a positive 5. And then the rest of it's just like what we've been doing. The only difference was that this symbol did have to flip. And if you don't flip the symbol, your graph won't come out correct.
Why you got flipped again?
Because we divided both sides by a negative number. So if you multiply or divide both sides by a negative, the sign has to flip around. Okay, and we can kind of check that or look at that when we graph our answers. So when we go to graph it, are we open or closed at 5? We are closed at 5 and we are shaded to the right. Now, if we hadn't flipped it, we would have thought to shade which way? To the left. And if we shaded to the left, we would have included 0 in our shading, right? Okay. So if it's shaded, it means it works as a solution. So let's test it. If we were to plug 0 in here, is 0 greater than or equal to 5? No. That's why 0 shouldn't be shaded. So if we were to plug in a number from somewhere where we did shade, like 6, is 6 greater than or equal to 5? Yes. So that's how we know that we have to flip it around so that we shade the correct space. It only happens when we multiply or divide both sides by a negative. Okay, and I'll be repeating that a lot. Any other questions before we do number 8? You got the answer? So what did we do to both sides? Okay. So again, we multiplied both sides by a negative number. Negative 3 times 2 gives me negative 6. What has to happen to my symbol? Switches around. And then the y is alone. So the symbol did need to flip. But are we ready to graph yet? No. Now what do we have to do? We got to flip the whole thing over, which means that our sign is going to flip around with the whole problem. So sometimes your sign will flip and then it'll flop back. Okay, we just have to keep track of it one step at a time. So first it flipped because we multiplied both sides by a negative. And then it flopped because we had to switch the whole thing around like we've done before. Questions about the sign flipping and flopping?
So when you flop the sign, like when you flip it, the first time you flip it all about, and then the second time you use the sign.
So when we did it, yes. So the second rule is just for the symbol in the middle when we multiply or divide by a negative. But the other time, which we'd already talked about before, is when you switch the whole problem around. You rearrange the whole thing. Now that we're ready to graph, am I open or closed at negative 6?
Open.
Open, very good. Shaded to the left. Good. We go based off of our final answer when the variable's on the left side. Yes. Yes. We are going to solve it by multiplying both sides by a negative 4. Because we multiplied by a negative on both sides, that does mean that our inequality symbol flips around. 7 times negative 4 gives me negative 28. Okay, and we do not need to rearrange it anymore because now our variable is on the left. It's alone. We can graph. Open or closed at negative 28?
Open.
Open, shaded to the right. Because when we were done, it was a greater than symbol. On number 10, how are we going to get r alone? Good. We divide both sides by a negative. That means we are going to switch the inequality symbol around. But are we ready to graph yet? No. Now we have to flip the whole thing. So the r is going to move, the 11 moves, and the symbol now flips back over again. No, signs don't, like positives and negatives don't change when we rearrange it. Okay. So I ended up with positive 11 because we had a negative divided by a negative. Same thing with the r. Those negative 2's would cancel each other out. Any other questions about it before we graph it? Okay, when we graph it, are we open or closed at 11? Closed. Shaded to the left. Good. Less than when we were done flipping and flopping, so we shade left. So, agreed. We multiply both sides by a positive 5, so that does not flip our symbol. We've got x is greater than negative 25. Are we open or closed at negative 25?
Open.
Open. It's probably, I'm a little high. open there and shaded to the right because it is greater than. All right. Questions about 11? All right, on 14, we're skipping ahead to 14. How did we solve this one? Multiply by the reciprocal. What is the reciprocal of negative 1/10? Negative 10 over 1. Or just negative 10. So on this one, we get z alone. Does our symbol flip? Yes, it sure does. 1 times negative 10 over 1 is negative 10. Open or closed at negative 10? Closed. We've got an equal to bar, and we shade it to the right because it is greater than. Questions, concerns? Okay, we'll keep moving. All right, on this one, you don't need to write the whole word problem down. We will talk about it. I will write down what's important, and that's what you should copy down as well. All right, you earn $9.50 per hour at your summer job. I would write that down, that your wage is $9.50 an hour. Write and solve an inequality that represents the number of hours that you must work to buy an iPhone that cost $975. So, we're trying to figure out hours worked. That's our unknown. So if we don't know how many hours we need to work yet, what should we use for it? A variable of some kind, if you want to work. Okay, I heard n first. If you want to use an x or an I, something else, go for it. And how much money are we trying to save up? Okay, we're trying to save or earn $975. That's our goal. That might be a better way of wording it. Okay, how do you calculate how much money you've made if you know how much you make per hour and you have an amount of hours you worked? How do you know how much money you've made if you get paid per hour? Multiply your wage times the number of hours you worked. That's how we know how much money we've earned. So we're going to take the $9.50 and multiply it by n. We need at least how much money? $975. So what inequality symbol is appropriate for at least? Greater than or equal to. We don't want it to be less than $975. We want it to be greater than or equal to $975. We want at least that much. So if we make more than that, great. Maybe we can buy a case to put on our new iPhone or something. But we need at least that much, greater than or equal to. If we go to solve this, what are we going to do? Good. Divide by the 950 or by 9.5. So how many hours are we going to need to work to make this happen? Okay, so we've got n greater than or equal to 102.6. Now, at most jobs, you're not going to work 0.6 of a job. So what do you think we need to do with that?
Round it.
Round it to 103. So we need to work at least 103 hours at our job to be able to afford that iPhone outright. Now, does anybody know how many hours most people typically work in a full-time job in a week? 40. 40 is typical for a full-time job. And that's assuming you don't have to spend your money on anything else. You could get that iPhone in a few weeks. But that's also assuming you're working 40 hours, which most summer jobs are not full-time. One more. You have at most $3.65 to make copies. So I would need to know that. That's how much money I have. I have $3.65 in my account that I can spend. It's not a lot. I guess I already bought that iPhone. Each copy costs 25 cents. One copy costs me 25 cents. Write and solve an inequality that represents the number of copies you can make. So, we don't know our number of copies. So we should use a variable. We'll go ahead and use x this time. So yes, I believe, Jay, shows that you that said multiply again? Mm-hmm. Yes, we would multiply what together?
365x. Yeah. No. 0.25x.
Good. We would multiply the cost of a copy by how many copies? So we're going to multiply the 0.25 times the x. That shows me what my total will be. How does that need to compare to my money in my bank account? Very good. Less than or equal to. I cannot overdraft on my account to make some copies. So I need to spend less than or equal to 365. Divide by what? The 0.25. Now again, this is not going to come out nice. So what did we get initially for x, Liam? What? 14.6. Now on this one, be careful how you round it. If x needs to be less than or equal to 14.6 copies, how do we need to round that? Round down. We can't round up because we're already saying x needs to be less than that. So we would have to round down. So we need to make 14 copies or less. That's all we can afford. Okay, there we go. Our homework assignment is on pages 71 and 72. We're doing number 2, 3 through 19 odds, 30, 33. I did. 27, 30, 33, 40 through 42.